Welcome to our webcast, The Business Case for Zero Post-Processing. My name is Julie Reese, Vice President of Marketing at RIZE Inc., and I'll be your host for today's webcast. This webcast is derived from a white paper written by Todd Grimm for RIZE called 3D Printing, the Impact of Post-Processing. The perception and promise of 3D printing are that it offers a digital workflow that's simple, fast, and automated, a process where complexity is free. That's generally true up to the moment that 3D printed parts are removed from the 3D printer. As soon as parts enter the post-processing phase, the automated push-button process becomes a manual operation that impacts time, cost, and quality. New 3D printer users are often shocked to discover what's really required to make 3D printed parts usable following printing. Longtime users, on the other hand, tend to accept post-processing as a necessary evil. Since all other 3D printing technologies require post-processing, experienced users accommodate the added burden and make operational adjustments. Post-processing is a non-value-added process that increases overhead and imposes limits. It complicates the 3D printing workflow, adds expense, and extends delivery time. For the 3D printing lab, where operations are centralized and run by a dedicated staff, this is certainly undesirable. But for the office environment operations, it's downright unacceptable, making it a technology that's best suited for the lab, rather than being a hands-on convenience for engineers and designers. Ultimately, the burdens of post-processing are an impediment to expansion by current users and an obstacle to broader adoption by those that have yet to establish in-house operations. This non-value-added process limits the frequency of 3D printing use, the viable applications, and the markets that are served. In the context of 2D printing, post-processing is analogous to the steps needed to prepare multiple copies of a report when printed on a basic desktop printer. The job isn't finished when printing is complete. Prior to distribution, the pages are collated, 3-hole punched, and inserted into a binder. This manual operation adds time and cost. However, a better analogy is to photography. The perception and promise of 3D printing is a process similar to digital photography. The moment after taking a picture, the images are ready for distribution. The reality is that 3D printing is more like film-based photography, where the photographer develops the images in a darkroom that houses equipment and chemical solutions. During development, the resulting photo quality and image effects are controlled by the photographer. Contrary to the 2D printing analogy, which adds only time and cost, film photography also requires floor space, equipment, and skills. Time, cost, equipment, floor space, and skill are the hallmarks of 3D printing's post-processing phase. Post-processing encompasses all of the actions that are performed after parts are removed from the 3D printer. There are two categories of post-processing, primary and secondary. Primary post-processing includes the mandatory steps that must be performed on all parts to make them suitable for use in any application. The steps vary by technology, but generally include cleaning and support structure removal. Experienced users often refer to this basic finishing level as strip and ship because the resulting parts lack any embellishment that enhances quality. This webcast focuses solely on primary post-processing. Secondary post-processing includes optional part finishing that improves the aesthetics or function of the part. Most commonly, secondary post-process includes sanding, filing, priming, and painting. However, it can also include machining or plating, for example. 6 companies contributed their post-processing experiences. These companies represent the automotive, consumer products, medical device, sporting goods, and architectural industries. I can tell you that 2 of these companies were Reebok and Newell Rubbermaid. We've been asked by the other companies to exclude their names, although rest assured, you'd immediately recognize all of these brands. Each noted that the post-processing time and required resources varied by technology and part, yet they kindly reported their typical demands. The time impact. According to these companies, prospective users should plan for 1 hour of post-processing for every 1 to 6 hours of 3D printing. This translates to a 17 to 100% increase in the total process time. However, the total elapsed time will often have a much larger increase, as we discuss later. All of the companies noted that time is dependent on the intricacy or the complexity of the part. For example, small intricate parts take longer to post-process than large simple parts. The staff impact. Staffing is another consideration for prospective users. The companies reported that the ratio of machine operators to part finishers, the employees that do the post-processing, ranges from 1:1 to 1:3. For smaller labs, an operator may split his or her time between file preparation, machine operation, and post-processing, which means that there's a labor cost, but the budget is no added wage expense. But once total throughput reaches a level where a single individual cannot perform both functions, additional staff will be required. The facilities impact. Facilities must also be considered. When providing ample room for required equipment and workspace to conduct post-processing, these companies report that they have floor plans that use 1/2 to 1 square foot for post-processing for each square foot of 3D printer space, plus equipment and utilities. Let's talk about the primary issues experienced by those 6 companies. It comes as no surprise that the biggest issues with post-processing are the added cost and the added time, which could be quite significant. Both time and money were noted by the 6 contributing companies as their primary concerns. Yet, the ranked priority for each varied and were driven by the current climate within the businesses. For example, cost was secondary for those that urgently need to accelerate delivery of 3D printed models and prototypes. The business climate and corporate goals also influence the perceived impact of the post-processing. For example, the wages paid for post-processing labor were viewed as a barrier to advancement and innovation, a throttle on total production, or a drain on financial resources. While the negative effects of post-processing are universal, the implications of this required step are interpreted through the lens of the organization's current challenges and goals. The cost impact. Post-processing adds cost to 3D printing operations in a number of ways, but the most cited aspect is labor cost. Using a fully burdened labor rate, the companies reported an hourly cost of $30 to $100. With 4 to 10 3D printers, the annual labor cost, fully burdened, ranged from $100,000 to $500,000. This equates to a direct labor cost for post-processing of roughly $25,000 to $50,000 per year per 3D printer. If the machine operator or another high-wage employee performs post-processing, the annual cost can rise significantly. When adding a 3D printer, this burdened labor cost must be included in annual operating budgets. The additive manufacturing technology leader at a medical device company said that when budgets are taken into consideration, adding one more parts finisher means that there's one less machine that I can purchase. For those that are already saddled with post-processing labor, the benefit of eliminating this task may not be cost reduction. Instead, it could be capability expansion. Considering budgetary limits that preclude hiring, the contributors indicated that they would reallocate the post-processing staff to value-added activities. For example, the medical device company stated it would redeploy its personnel to activities that either improve its 3D printing operations by advancing the technology or redirect the staff to secondary post-processing activities that improve the quality and appearance of 3D printed parts. Michael Zerbe, the RP technology supervisor at Newell Rubbermaid, noted that staffing limitations impact part quality and 3D printer utilization. He said that without primary post-processing, the staff could invest its time to improve 3D printed models with additional finishing and painting. But more importantly, he could increase his 3D printing output. He said, "With my post-processing resources, I can only run my 3D printers at a 60% utilization rate. Eliminate post-processing, and I'd have the capacity to run them around the clock. This would mean more throughput, which would allow us to do more iterations for each project." Another expense element related to labor is the increased cost for models and prototypes when demand exceeds the capacity of the post-processing team. An engineering manager at a consumer products company noted that during peak periods, he may have the need the needed 3D printer capacity, but lack the required post-processing resources. In these situations, he either has to pay overtime or subcontract the work to a service bureau. He noted, outsourcing increases the part cost by 3 or 4 times, and we can't deliver as fast as if we keep the work in-house. The time impact. A key benefit of 3D printing is speed, so anything that slows the process is undesirable. Although a single part may be post-processed quickly, the aggregate effect can extend lead times by days or even weeks. As the contributors shared, post-processing adds 17 to 100% to the 3D printing time on a batch-by-batch basis. What those numbers don't reflect is the full impact of this manual bottleneck operation on schedules. A few hours of post-processing can translate to a 24-hour delay, even with a well-staffed operation. When compounded across multiple design iterations, the delay can be measured in weeks. At Reebok, a typical build time is 8 hours for its material extrusion process. The 3D print jobs are then followed by post-processing, which may include a 4-hour soak to dissolve the support structures. This semi-automated step adds 50% to the total process time, but the total elapsed time to deliver the part can increase by 350% to turn 1-day delivery into 2. According to Gary Rabinovitz, the company's RP lab manager, post-processing can add another day to the schedule, which means that the design review and release of the next design iteration are also delayed. For example, if a file is received in the morning of day 1, the build could be launched at 9 a.m. With an 8-hour build, 3D printing finishes after hours at 5 p.m. Support removal starts first thing in the morning on day 2 and finishes at noon. This 8-hour print has a 36-hour turnaround, even if the schedule is wide open and staff is available. Of course, a second shift could accelerate the process, but as discussed earlier, that second shift would add an expense that budgets might not support. Without post-processing, delivery and design iteration could occur 1 day sooner. The cumulative effect over multiple iterations may extend a week or more, as one consumer products company noted. Its engineering manager said, "If a build ends in the afternoon, and if there was no post-processing, we could have the next iteration building by the end of the day. With post-processing, it's pushed out a full day." This company typically does 5 to 10 iterations for each product, which translates into a total delay of 1 to 2 weeks, if weekends are included. For these companies, eliminating post-processing would dramatically accelerate the product development process, which in turn can reduce the time to market. At the day-to-day level, post-processing may be the difference between delivering in time for an important meeting or walking in empty-handed. Another factor that adds to the potential for delays is that post-processing can be a bottleneck that's subject to backlogs. The automated 3D printing process typically outputs many parts per build, which all enter post-processing at the same time. Considering the need for direct labor and access to the supporting equipment, parts wait in a queue until the resources become available. The additive manufacturing technology leader at the medical devices company said, "It kills me to see trays of parts late on a Friday, knowing that they won't be delivered until late in the day on Monday." The automotive company noted that the bottleneck becomes very evident following a long weekend. Leveraging the unattended operations, as many parts as possible are nested to print in one long run over the 3 days. However, post-processing resources are overloaded when work resumes. A casting engineer at the company said, "There are backlogs even if post-processing is automated. Sometimes post-processing equipment simply doesn't have the throughput or capacity to match that of 3D printers running over multiple days." Without post-processing, the value of 3D printing could increase substantially. For some, it would allow them to perform more value-added tasks to improve part quality and expand the application base. For others, it would dramatically accelerate the total process, which increases responsiveness and total throughput. For those adding new 3D printers, eliminating post-processing would reduce labor expense by $25,000 to $50,000 for each machine. However, post-processing's burdens don't stop with labor cost and total process time. Post-processing's impact is far more widespread than the cost of labor and the delays on schedules. While considered to be secondary issues by these 6 companies, the impact on quality, staffing, facilities, and safety can't be ignored. First, quality. Ultimately, the quality of 3D printed parts is in the hand of the part finishers that wield X-Acto knives, sandpaper, and spray nozzles for media blasting or water jetting. The medical device company noted that maintaining consistency and accuracy across many copies of the same part is difficult when manual labor is involved. For intricate parts with delicate features, a consumer products company said that it often opts to build a duplicate just in case the original is damaged or broken. But making duplicates increases cost and consumes valuable 3D printing capacity. For those that have the budget to hire post-processing personnel, the issue of staffing becomes one of finding the right talent. According to a consumer product company's engineering manager, post-processing is kind of an art form. Part finishing requires a unique skill set and a unique personality. To maintain the quality of the 3D printed part, the post-processing personnel must have model-making skills, manual dexterity, and experience with the tools at their disposal. Yet they must also demonstrate those skills while under intense pressure to deliver rapidly. Of the entire labor pool, only a small percentage possess this combination of skill and temperament, which complicates the hiring process. Floor space is required to house the staff, workbenches, and post-processing equipment. As we stated earlier, a ratio of 1/2 to 1 square foot per square foot of 3D printer space will be needed in many cases. This space can be an impediment for those that don't have the option to expand into existing areas, an expense for those that have to take on construction, or an ongoing cost for those that have internal cross charges for floor space used by the department. Another cost consideration is the purchase of the workbenches and equipment, which will run into the thousands of dollars for the typical, yet small, 3D printer lab. There's also the additional cost to run utilities, like electrical, water, and air lines, to the equipment. Safety. Safe operations, safe handling, and safe disposal are sources of hidden costs that many don't account for until after the implementation of the 3D printer. According to the medical device company, the organization has a rigorous safety program, which means that more safety resources are required for each employee added to the post-processing staff. Additionally, it noted that the 3D printing operation is the largest generator of hazardous waste in its entire R&D facility. Proper disposal of hazardous waste generated during post-processing is quite costly. In a lab environment, the issues and limitations created by post-processing are impediments to throughput and part quality, as well as a drain on budgets and resources. In a design or engineering area, these issues are a significant barrier to adoption. 3 of the 6 companies expressed an immediate desire to deploy 3D printing in offices while maintaining the existing 3D printing lab. The advantages of distributed 3D printing is that a designer or engineer would have quicker turnaround, both for the office-built and lab-built parts. Placing 3D printers in the office space, the self-start model is more responsive because it sidesteps the work queue of the lab. Meanwhile, the lab is more responsive because it offloads the work for basic models and prototypes. Yet all agree that office deployment is not reasonable when primary post-processing is required. The architecture firm cited a messy and unsightly work area. The automotive company cited chemicals and equipment. And a consumer products company cited the high burdened labor rate for engineers to execute part finishing. For 3D printing in the office to become realistic, it must mimic the workflow of a full-feature 2D printer or digital camera. It becomes realistic when a single device outputs ready-to-use items with no requirement for additional labor, equipment, and floor space. It becomes a viable option when skill, temperament, and safety are no longer considerations. Eliminate post-processing, and it becomes feasible to place 3D printers within the work groups that need the models and prototypes. Eliminate post-processing and 3D printer labs become more efficient, more responsive, and less costly. Post-processing is a non-value-added function that's both a burden and a bottleneck. Without it, as RIZE has accomplished with our augmented polymer deposition 3D printing technology, the promise of a simple, fast, and automated digital workflow becomes a reality for all parts, whether simple or complex in design. In that new reality, 3D printing adoption will accelerate, and the breadth of applications will expand for organizations of all types and sizes and for every industry and market. Thank you for attending this webcast. Please visit our website at www.rize3d.com.